Good
So
morning,
in the
sir.
last
Morning, sir.
in the last class we have studied the very brief about the course, the the entire syllabus of the course, how it is designed, and what are the different module, how we will be studying in the class that we have discussed. And very briefly we discussed what is operating system, what is the major functions of operating system, and what are the building block of operating system. Okay, so today we will be going more detail about it. Okay, some more functionalities of operating system, how it exactly works, and how the different pillar of operating systems support it to do those things. So what is operating system? The program running at all the time on the computer. That means when you switch on your machine, the operating system program is loaded from your secondary disk to primary memory. You know that primary memory or RAM is a volatile in nature. That means so far the power is there, the data informations will be there in the main memory. The moment there is a power cut or the moment you shut down your machine, there will be nothing in the main memory. On the other hand, to enable a program to be executed, you must have to load the program from your secondary disk to primary memory. For example, you can write a program in one machine and you save it in your pen drive. You can carry that program with your pen drive from one machine to another machine. Now, while you go to that new machine, you have to insert the pen drive as it is a secondary drive. So you have to insert that pen drive and you have to give proper command or instruction to the system for execution of the program. Now, the moment you give the program, the moment you give the instruction to the computer to execute that program which is in your pen drive, operating system will copy the program. Operating system will copy the program from your secondary disk. Maybe it is in a pen drive or maybe in a CD or maybe in the hard disk. It will copy from that secondary drive to the main memory. Once the program is in the main memory, then only it can be executed by the CPU. With the same analogy we can draw that operating system is a set of program. Operating system is a set of program written in some programming language. Okay, so initially the operating system is in the either in your hard disk or maybe in your bootable CD or maybe in a bootable pen drive. The moment you switch on your machine, it will copy the part of the operating system program from secondary disk to main memory. Then it will be executed. And as a result, you can get the interface of your system to work on it. So that means the moment you start the machine until you shut down your machine, in this complete phase, the operating system will be keep on running in the background. And that set of program of the operating system is called the kernel. So kernel is very core of the operating system, which is always running when you switch on your machine. I mean, during the moment you have the machine is on, your kernel program will be executed. So obviously, if you want to allow it to execute it, it must have to reside in your main memory. Otherwise, it is not possible. So maybe you may have a 4 GB RAM or 8 GB RAM or 16 GB RAM. A part of the memory, part of the RAM will be always allocated with the kernel, which is a part of operating system, which is always keep on executing. Otherwise, it will not be, the machine will not be on, or machine will not be able to provide you the interface as it requires. And this, so you have already the term, or you are familiar with the term booting. Okay, what is booting? Can anybody say?
So the system starting up.
Bolo, Amullah, bolo, Amullah.
So the system starting up, sir.
System.
So the computer system starting up, sir, like the loading of programs when you switch on the computer. The entire
That's
process.
it. Or kuch? কি হলো তোমরা তো অলরেডি কম্পিউটার অর্গানাইজেশন পড়ে এসছো what about the other people
So the necessary resources are loaded onto the main memory, like the kernel and other system software application system programs.
so initially your operating system is in the secondary disk when you at the first time when you switch on your machine a part of the operating system program will be loaded from secondary memory to main memory. This is one of the functionality of booting. Of course, there is another functionality. At the same time, it will check all the peripheral devices of the system is properly connected or not. If somehow one of the device or maybe your RAM is loose, your hard disk is loose or something like that, it will immediately give you a knock, a signal. So one is copying the operating system program or the kernel from secondary disk to primary memory. This is one function of the booting. The second part of the booting is it will check all the devices, all the hardware components are properly connected or not. These are the two things that takes place during booting. Now, many of you have the experience of executing your running your machine with a bootable disk. You don't have operating system in your hard disk and you want to install. So what you can do, you can make a bootable pen drive, maybe with Ubuntu, maybe with a Windows. You can start your machine from your bootable pen drive. That means the same thing happens also here. A part of the program or the kernel of the operating system will be loaded from your bootable pen drive to main memory. And you can work on that machine without even installing it in your own hard disk. So basically here, the operating system program is loaded from secondary to primary memory from your bootable disk. That is the thing. Apart from the kernel, everything else is a general system program or maybe an application program. A program that acts as an intermediary between an user of a computer and the computer hardware, as I told in the last class. You purchase a new machine, all the components of the machines are connected properly, but still it is not in a workable conditions. You need to install a proper operating system which will establish a connection or logical connectivity among all this computer, all this component, and gives an interface to the user such that user can interact with the low-level hardware. So operating system is a program that acts as an intermediary between an user of a computer and the computer hardware. So this is one thing. The second thing, it manages all the hardware resources. It manages all the hardware resources. Manages means it uses all the hardware resources in efficient manner. And that's why the term come into the picture is manager or manages. Because you have number of CPUs, maybe 1 CPU, 2 CPU, 4 CPU. You may have 4 GB RAM, you have 8 GB RAM, you may have 16 GB RAM. You may have 1 TB hard disk, 2 TB hard disks. Okay, you may have dual monitor, you may have dual keyboard. So all the devices, you may have a dual printer or single printer. So all these hardware component needs to be managed and that responsibility is with the operating system. Operating system takes the responsibility of managing all these hardware resources. Without operating system, that is of no use. In the same way as we have brought the analogy yesterday's class, that in a particular semester, you have a different theory subjects, you have a different lab. Each of the subjects has a fixed curriculum or fixed syllabus. Lab has some fixed syllabus. Their requirements are different. Lab may be of 3 hours or 4 hours. It needs to be consecutive. On the other hand, the theory 3 hours or 4 hours per week, and that 3 hours cannot be in a consecutive in a one day. Similarly, there are different faculty members who takes these classes. And each of these faculty members, apart from taking your class, there are a lot of other activities, taking the classes of other batches, as well as a lot of administrative activities. Apart from that, there are some physical resources, availability of the classroom, availability of the availability of lab, availability of projector, and the foremost thing requirement is the time. You have a time constraint for each of the subjects. Why? Because you have a midterm exam, you have end-term exam. So before the midterm exam, each subject must have a definite syllabus that needs to be completed. Similarly, before the end-sem exam, all the syllabus for all subjects must be completed. So requirement, time, resources are different, and that's why you need an efficient scheduler, a schedule or a class routine, such that requirement of all the subjects, all the labs in a particular semester must be fulfilled depending on the resource available. That's why you need a class routine. In the same way, operating system is nothing but it is a set of some kind of scheduler which schedule for uses of different resources. The resources may be RAM, the 4 GB RAM or 8 GB RAM or 16 GB RAM, depending on the size of your machine. You may have quad core, 4 core, hexa core. You may have different size of the hard disks, maybe 500 GB hard disks, 1 TB hard disks, 2 TB hard disks. Now, interestingly, whether maybe two of your roommates, one purchase a very, with a desktop or maybe single core with a 500 GB hard disk. Another person's purchase in the same day with a different configurations, maybe quad core processor, 2 TB hard disk, 16 GB RAM, etc., etc. I mean, the configuration is different, but you can install the same operating system for both the cases. So your operating system should be smart enough to handle both the resource efficiently. That means you cannot buy or you cannot install separate operating system, because today if you want to if you purchase a laptop, and if you want to go for installing an operating system, of course you will be going for the latest operating system, Windows 10 or Ubuntu, the latest version, Ubuntu or Fedora. So that operating system must have the functionality to use the 4 GB RAM as well as 16 GB RAM. It must have the functionality to use 500 GB hard disk or 2 TB hard disk. That means that you cannot customize your operating system. I mean, the operating system manufacturers are same. I mean, the same features of the operating system is there. This operating system has the capability to use this configuration as well as different configuration. So computer system, it may have one or more CPUs. Apart from that, there are device controllers that connect through common buses. So you have CPU, and that CPU is connected with the main memory. So this is your CPU. You may have 2-core, quad-core, or hexacore, whatever. But all the CPUs, all these core are accessing the same memory module. Maybe it is a 4 GB RAM or 4 GB RAM or memory, or it is a 8 GB RAM or 16 GB RAM. But there may be 1 CPU machine, 2 CPU machine, or 4 CPU or 8 CPU machine. So the same memory module is being accessed by these parallel CPUs simultaneously. Now, how this 4 GB, 8 GB, or 16 GB RAM will be partitioned on runtime such that it can serve the requirement of all the CPUs. Or sometimes you are running your 4 processes, 4 programs, application program. Sometimes you are running 16. The very high computation game. Sometimes you are running a very just a browser. So how your memory, because for all the programs to be executed, the program must be loaded in the main memory. That is the primary thing that I told today. To enable a program to be executed, the program must be loaded in the main memory. Whether it is in your hard disk or in your pen drive or CD, it must be loaded in the main memory. So if you want to simultaneously execute 5 programs, then the memory requirement for all the 5 programs must be satisfied. And moreover, the requirements of those programs are different. Someone is looking for 500 KB space, someone is looking for 1 MB space, someone is looking for maybe 10 MB space, which is a game. So its requirements are different. So all the requirements must be fulfilled by the operating system. So operating system acts like a manager which manages the main memory. In the same way, we can bring the analogy that you have a CPU that may be 2-core, maybe quad-core, maybe hexa-core. Sometimes you are running 1 program, sometimes you are submitting 5 programs. Sometimes you are giving a very high computing program. Maybe you are hello?
Yes, sir.
Yes, sir.
There is a power
Yes.
change. Yes. Sometimes you are submitting a large program which consists of number of sub-components, some execution that we will be discussing in more detail about in upcoming chapters. So how this 4 CPU or 2 CPU can be used efficiently to execute all these concurrent programs? And that's why there is a need of process management or processor management. So one is memory manager or memory management, other is CPU management. Apart from that, all the peripheral devices that you have, maybe you have disk, you have keyboard, you have printer, you have monitor, all are having some controller. So controller is nothing but it is again a program. Again, it is a program that needs to be installed. Either it should be pre-installed or you need to install separately to make that particular drive or particular device workable condition. Have you heard the term device driver? Anybody?
Yes, sir, it's a software. for
Ramprasad,
effective running of a particular device.
have you come across this situation anytime? Saptaji, have you come across this situation?
Yes, sir. Like connecting a Bluetooth speaker sometimes asks that if there's a problem, they say that driver not running on.
Okay, good. All good. Anything else?
So when connecting the mobile phone to the laptop via a cable.
Why?
While connecting the mobile phone to the laptop via a USB cable.
You need to install
Yeah.
some device driver. Okay. So device driver is a system software which is, you can say, as a controller to drive that particular device. So by default, majority of the device program are already in the modern operating system. For example, very interesting example I should give here. In our time, we were Windows 98. Okay, before that 95, and then in my machine it was Windows 98. Okay, so when we were in a third year or fourth year, there is a new concept come in the picture, was pen drive, this flash drive. Earlier to that, we were familiar with floppy. Have you heard the term floppy?
Yes, sir.
Yes, sir.
Floppy.
Yes, sir.
Floppy. It's a kind of magnetic device, but the size is very, very less. I mean, maximum you can carry a CV or maybe 2 or 3 images. It is 1.44 MB, megabytes. 1.44 MB, 1.44 MB megabytes, MB. So that was the only option for us to carry anything, maybe program or anything. So when this the pen drive come into the picture, there are some machine in our batchmate whose USB port was there, but USB pen drive cannot be recognized by the system. So in that time, if you purchase a pen drive also come with a CD. Whenever you purchase a pen drive, the pen drive will come with a CD. What is that CD? The CD has the device driver which needs to be installed to use your pen drive in your machine. Because Windows 98 operating system does not have the device driver for pen drive. Windows 98 operating system did not have the device driver for running to recognizing a pen drive. So you need to install a separate device driver for pen drive, and that device driver used to come with a CD in the box of pen drive. But today, if you purchase a pen drive, you don't need to install separate device driver, because the pen drive is so common. Today, pen drive is so common that all the operating system you use today are already having that device driver. Am I clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
But tomorrow, suppose you are going for purchasing a new device, which is very unknown device. It's a very uncommon device or very unknown device, and if you install that device driver, then you have to install the device driver for that. For example, you can see these are can you see this thing?
Yes, sir.
Yeah. So this is a Wacom device where I can write something. It's a board. It's a board for taking the classes and notes and all. So this is a very new device. During this lockdown session, University NIT Durgapur has provided one device for each of the faculty members. But unfortunately, this device is so new that all the existing operating system does not have the driver for it. So what I need to do, I need to download the driver for it separately from their website, and I have to install it in my Windows machine as well as the Ubuntu. So for both the operating system, there is a separate driver for this device. I had to download the driver and had to install separately for Windows machine, for Ubuntu machine. Now it is in a workable condition. Otherwise, it could not be recognized by the system. But for pen drive, you don't need, because pen drive is so common that all the operating system come with the driver of pen drive. Okay?
Yes, sir.
So here you see, as I told, that each of the devices are connected with some kind of controller. So controller again is that software which is already in the operating system if it is already known device. But if it is unknown device, then you have to install separately. And for most of the unknown device, they provide the driver on their website. You have to download it. So IO devices and CPU can execute concurrently. You may have a number of IO devices. Of course, you will have CPU. So they will work concurrently. Each device controller is in charge of a particular device. Maybe there are 4, 5, 6 USB port in your machine. So there must be a USB controller which will control these pen drives. CPU moves data from and to main memory and to and from local buffer. So each of these devices has a buffer. Buffer is a temporary storage. Where while transferring data, temporarily data can be stored. For example, your printer at a time can print single file, or rather single page. So suppose you have given a continuous 3-4 file to print. Of course, that 4 files cannot be printed simultaneously. It will be printed one at a time. So while the first file is printed out, the remaining 3 files will be kept in the printer buffer. The remaining 3 files will be kept in printer buffer. So there is a very small amount of memory that is allocated for printer buffer. So one job is getting done, whether the remaining jobs are in a buffer. Device controller informs CPU that it has finished its operation by causing an interrupt. Can you remember while you write a program in C, the scanf function?
Yes, sir.
Yes, sir.
Yes, sir.
এক মিনিট দেখো, দেখতে পাচ্ছ কিনা?
Yes, sir.
Suppose you have a main program. You have some instructions. Then again, what is the meaning of this scanf function?
That it accepts user input.
It accepts user input, right?
Yes.
Yes, sir.
Any doubt with anybody?
No, sir.
So it will be, the program will be executed, the instruction one at a time. While it comes to this position, this instruction will not be completed. This instruction will not be completed unless there is an input from keyboard. Am I clear? This scanf instruction will not be executed unless you give an input from keyboard, because to complete the execution of scanf function, there is a need of a keyboard input by the user. Once you give the input from keyboard, the next instruction will be executed. So while CPU come to this point, CPU will be halted. CPU will be halted and it will not go further unless it receives an input from the user. Unless it receives an input from the user. So it will be halted, stop ho jayega. The moment you give an input, maybe you give an input 5. The moment it receives an input 5, the keyboard controller will give a notification to the CPU. Ki, you were waiting for me, I have done my work. Now you can proceed further. Just the thing that happens like this. So the moment this position is coming, CPU will be halted and it will be expecting an input from user through keyboard. Unless it receives an input from the keyboard, it will not proceed further. When you give an input from the keyboard controller will give a notification to the CPU that I have done my work, now you can proceed further. This is called interrupt. দেখতে পাচ্ছ? Hello.
Yes, sir.
Yes, sir.
So device controller informs CPU that it has finished its operation by causing an interrupt. It will say that I have done my assigned work. Now you can process further, or you can proceed further. That's it. So, as you are already familiar with this thing, computer system can be divided into 4 components: the hardware, the low-level hardware component, operating system, then system and application program, then your compiler, assembler, text editor, database, maybe DB2, Oracle. Similarly, for compiler, you can have GCC compiler, you can have Turbo C compiler, or maybe you have Python interpreter like this. Similarly, you can have different text editor, OpenOffice, LibreOffice, Microsoft Word. So this is this layer. And then, apart from that, the outermost layer is the user. So there can be n number of users. So operating system is a resource allocator. Resource allocator manages all the resources and decides between the conflicting resource for efficient and fair resource use. There is only one classroom for 5th semester and 7th semester CSC. So while preparing the routine, it needs to be take care that the two classes, 5th and 7th semester, cannot take place at the same time, because that will lead to a conflict. So I have a single common classroom for both 5th and 7th. So we have to schedule the meeting such that their classes can be taken in time sharing basis. What do you mean by that? Follow. Pranit Pandey.
Yes, sir.
Follow.
Time sharing basis means time sharing basis. It's kind of like our schedule, the classroom schedule that we follow, because two classes cannot occur in the same class, in the same classroom at the same time, or the lab.
So
two classes can't do the lab in the same time. So operating system acts like a time. Time is also a resource. So it is allocating that resource accordingly, so that all the processes can use that time effectively.
there is a very common example. I don't know whether you have faced in the hostel or not, because you are very unlucky batch that you cannot. I mean, you did not get the time to enjoy your hostel life. So in the hostel, if you go to the hall 4 and hall 5 particularly, I was in hall 1 for 2 years and 2 years in hall 4. First year, second year in hall 1, and third year. And in our time, from third year onwards, we are given single room. So third year and fourth year, we were in hall 4. So typically it is in the senior batch it happens. There are only 4 or 5 bikes in the hostel. Bike. Okay. And nobody knows whose bikes are there. I mean, they were inherited by from the seniors. I mean, who was the owner? Who is the? I mean, no news about that. So the condition is that you can use the bike, but you have to put your own fuel. That is the only condition. So hostel का common रूप पे रखा हुआ है bike. You can use the bike, no harm about it, but you have to put your own fuel. So of course you have to manage the time, because many people may try to access the bike at the same time. So if 2 people try to access the bike at the same time, so there will be a conflict. So either you can make some kind of time sharing, or you can make some kind of scheduling. So there are different resources, different type of resources that is available. How you can allocate such that there won't be a conflict. There won't be conflict. In the same way, operating system, you have dual CPU or quad core CPU or whatever, and you are trying to put more and more program on it. So how the CPU will be allocated, or CPU cycle, the term is CPU cycle, will be allocated for executing this program such that there won't be a conflict. So it may be the conflict from the perspective of CPU uses or CPU cycle. It may be the conflict of usage of memory. It may be the conflict of usage of IO devices. 2 people trying to access or 2 program trying to access the same IO device at the same time. Maybe your webcam. You are accessing through Google Meet. You are also trying to access it through MS Team. There is a conflict. So operating system needs to resolve it. Which one to give the access? Similarly, this is not only with the I/O devices, there can be registers, there can be files, there can be databases. So there can be different types of conflict while accessing different resources. OS is a control programmer which controls the execution of program to prevent errors and improper use of computer. So your program, your system is ready and you want to execute a program. Maybe you have written the program in Python or C, whatever. The program may be in your secondary disk or maybe in a pen drive, whatever. Now you have to give a command or instruction to the system that I want to execute my file. The file location of the file is this. The location of the file is this, and I want to execute this file or this program. So what you need to do? Operating system will copy the program from secondary disk to main memory and will start executing. Now there may be several such programs waiting to be executed. So how this program will be scheduled? So this is called OS is a control program. It controls the execution of program to prevent errors or improper use of computer. So the second part is more like a process manager or process management. Okay. So So history আমি আর পড়াচ্ছি না এখন। Now if you see the evolution of operating system, the first evolution was in 1950, and that was the early system. That was you have only one computer and you have to write the program in some kind of card, just like the floppy. So at a time you can write one program. With that program you can go to the system and you submit for execution. So one program at a time. There is no in-between interaction. So the system is not interactive. Then in 1960s, the operating system come with the concept of batch operating system. With the same card concept, you can write 5, 6, 7, the batch of program at a time. You can have a batch of program at a time, and you can submit that set of program to the system for execution. The operating system will take one task at a time. That means it's a kind of serial execution. The term is serial execution. So you submit 10 tasks or 10 programs to be executed. It will take one at a time. So all the 10 programs are stored in computer, in your card. Mind it, again, this is not interactive. That means whatever input that you want to give, you have to give in the card itself. During runtime, you are not allowed. During runtime, you are not allowed to give any data as input. Clear? Next comes the concept of interactive operating system. What is interactive operating system? During the execution, you can give some input. You can interact with the system. You can interact just like the today's operating system. You can interact. Next come in 1970s, the multi-programming batch system. It is again a batch system like 1960s, but the concept with multi-programming. That means you can give multiple program in the batch and all the multiple program will be executed. So these two things come in parallel actually, multi-program batch concept and multi-program batch concept and time sharing concept, because that multi-programming will be executed by a batch system in time shared manner. So maybe that time shared is maybe for first program is given 2 seconds, then second program 3 seconds, fourth program given 5 seconds. Then again it start from first program, second program, third program. So it may be in a different types of schedule. It may not be the sequential execution. Even during the execution, the program may be switched from one processing mode to IO mode to processing mode. For example, while one process is doing some kind of input-output actions, the other process is being getting executed by the CPU. So it is a kind of multi-programming and multi-programming time shared basis. And then it comes with a real-time system. Whatever job you are submitting, that job has a fixed deadline. The job needs to be completed with a fixed deadline. The idea is that each job is associated with a deadline. If the system can execute that job within this deadline, the efficiency is 100%. If it cannot execute that job within this timeline, then maybe the output is 0 or the efficiency is 0, or there can be some kind of catastrophic. For example, all the rocket system, the aircraft system, this type of things are called real-time system, where the operating system is running, but operating system is the job that are coming to this operating system is having a deadline. It must have to complete it within that deadline. So if the job is come with a deadline and that deadline is a very serious parameter, then we will say it is a real-time system. And then we have come multiprocessor operating system, which we are familiar today. So today's operating system all are of multiprocessor system. So if you purchase today a laptop, it is of dual core or quad core or hexa-core processor. And whether you install Windows 10 or Ubuntu or Fedora, that must have the capability to use that multiprocessors. So basically, if you go for quad core or multi-core processors, so in a single see here there are 3 CPUs. All the CPUs are connected with a single memory module. So today, whatever computer we are purchasing is of this type. There can be 4-core or 2-core or 8-core or 16-core. And whatever RAM you have, 2 GB, 4 GB, 16 GB, that RAM is being shared by all the CPUs. So this is a multi-programming based, a multiprocessor based system. Multiprocessor based system. Then we have advanced operating system like distributed operating system, network operating system, where you are not looking for the thing that you are executing. It can take the resource not only from your computer, rather it can take the resource from some remote machine. The best example in today is most of you are familiar with Dropbox or Google Drive. You feel that you are keeping your all important file and data in Google Drive, but actually those files and data are not being installed in your own machine, kept in your own machine. Rather, you are using the hard disks of someone else. You are booking a ticket in IRCTC. So basically, booking a ticket means nothing. You are accessing the database of someone else. IRCTC is a company which has a database, and you are trying to manipulate that database sitting at your own machine. That is distributed system. So to enable this thing, you need an operating system called distributed operating system. Similarly, you have network operating system, okay, web-based operating systems. These are some kind of advancement which are used for most of the web-based and distributed systems. Okay, another thing that I need to show you. If you look into the RAM or the memory module, whatever it is, a 4 GB RAM or 8 GB RAM or 16 GB RAM, the top of the space reserved for the operating system to be copied, the kernel portion, as I told in the beginning of the class. So this program will be always there till the machine is on, because RAM is a volatile. The moment the power cuts or shut down your machine, everything will be wiped out. So the moment you boot your system, a part of the operating system program or the kernel will be copied from secondary to this place of the main memory and will be executed till you shut down your machine or there is a power cut. The remaining portion of the main memory is called the user space, where the job you are submitting, the program you are submitting, the application program you are going to execute will be loaded. So this space is called system space. The top position is called the system space. The lower position, this portion, is called the user space. System space is for running the operating system program. The lower space is for running the user program. Now you have four jobs you are submitting simultaneously, or you may submit 10 jobs simultaneously, or even sometimes you are submitting one big job. So how this user space will be allocated to execute that program, that is the activity of the operating system. It is the responsibility of the operating system to use this user space to allocate those incoming programs for execution. Bolo, any doubt with today's discussion?
No, sir.
Sir,
Yes, sir.
কার্নেলের সাইজটা আমরা কি করে দেখবো?
কার্নেলের
সাইজটা কি করে দেখবো? কতটা?
So yes. So mind it, the machine that you are using, you may have dual board system. Windows with Mac, Windows with Ubuntu, Windows with Fedora with Ubuntu, whatever. That means the same set of hardware or the same set of hardware configuration is being used to execute the same operating system or the same or different operating system. Same set of hardware configuration is being used for different operating systems. Sometimes you are using Windows, sometimes you are using Ubuntu. So this space is the size-wise, mind it, the term, the size-wise the space is not fixed. Size-wise the space is not fixed. That means depending on the operating system, this size will be changed. But the concept-wise, this space is always at the top of the main memory. concept wise it is always in the top of the main memory. So if you have a 4 GB RAM or 8 GB RAM, the top of the main memory, this space will be used for copying the Ubuntu kernel or Windows kernel. But that size depends on the operating system to operating system.
Sir, does that size also depend on the RAM memory size we have in that device?
No.
Okay, so
because the same machine, because the same operating system, sometimes you are using on 4 GB RAM or 8 GB RAM or 16 GB RAM, and that's why I should tell you that while you are going for, or while you are exploring a new operating system, each operating system must have its configuration requirement. Have you seen it?
yes, sir, we have.
Yes, that is this. Maybe even I should also tell you that my system, which I purchased during my college days in Ari College NIT Durgapur, it was Windows 98, and the RAM size you cannot imagine. It was 64 MB RAM, 64 MB megabytes, and the hard disk was 10 GB hard disk, 10 gigabytes hard disk, and we were happy with that. We used to write the program C, at least C, C++, Java. That much we did. That time we don't have Python, but C, C++ and Java. We were able to write the program. Even sometimes we play the game, the road race and all. So that time 64 MB RAM was sufficient for Windows 98. But today, of course, the functionality that we have or our requirement had changed such that even 1 GB RAM or 2 GB RAM is not sufficient to run Windows 10 machine, Windows 10 operating system, because Windows 10 has a minimum requirement maybe of 4 GB RAM. Clear? Yago, any confusion?
No, sir.
No, sir.
চলো তাহলে দেখো কিছু অসুবিধা থাকলে আমাকে বলো। আচ্ছা, ফ্রাইডের ক্লাসটা কখন আছে? এই 9টা থেকে আছে। হ্যালো,
Yes, sir. Yes, sir.
ওটা কি 11টা থেকে কটা যায়? তোমাদের তো ক্লাস নেই ওই সময়টা।